Hello guys, and is this working properly? Let's see if I can turn this chat thing into an actual sort of widget here. What's the size of this? Maybe this will do. And can I actually add a new widget that captures that chat and puts it on the screen? So I'm just setting up the stream right now. We will start in about 2 to 3 minutes, I'll say. Window capture.
Hey, that's pretty good.
Yeah, unfortunately it's not letting me. What about if I went on YouTube and looked for the actual link? There you go. Let's try the YouTube link. I know that that YouTube gives you a link to the chat. I just don't know where to find that. Because then I can turn that into a widget thing. I don't know where to find that. There you go. Apparently this works. So let's try again. So I'm just going to turn this into an actual widget on OBS. So and let me turn that into a very big size just to have it around. Let's say about this much. I guess it will do. Okay. And I can now edit this. I'll put it behind myself and Spotify above that. Okay. Here we go. And now how do I turn this into a little bit transparent, I guess? Where is it? Blending mode. Okay, that's not quite working, is it? And also, does it actually work if I just type a message? So if I... No, it doesn't update if it's not focused, unfortunately. That is a bit... It's a bit bad. Maybe we just leave the chat then. It's not going to work today. I'm going to remove chat. And let's actually get into the video. But just one test before that, I'm gonna check the volume when I'm talking, just to make sure that the volume and Spotify, they sound okay. And I can now edit this. Okay, it sounds about fine. So if you guys have any issues with the actual audio, please do let me know, and I can turn up or down the audio if necessary. So let's actually get into the video, into the stream of today, and it's basically just a continuation of whatever we had a couple of days ago, where I showed you guys one of the interview challenges that I got for a job interview back in the earlier in the year. And the challenge was to basically create a REPL library. So for those who don't know, REPL is basically just like a little interpreter, kind of like Bash, those on the terminal, where you can add your commands, and then the users can essentially just type in those commands with the arguments, and then the program will execute them, will show it on the screen, and then it will rinse and repeat, essentially. So that's what kind of REPL is, and the challenge for this interview was to create a library for that backend, for the command interpreter backend, essentially the thing that actually interprets a command given by the user. And I did actually push all of this to the Git repository here. It's called REPL interview. I'll post it on the link description. Oh, sorry, on the video description. If you're interested, I'll actually put it in there right now, just in case you guys are actually interested in looking at the code and the specifications. So everything is there, so you can actually take a look at the specs for this challenge. Let me just change that on the video itself. And I have now added it. And essentially I did have some initial code that kind of just works. It's not the best sort of approach to this problem, and this is why we're here. This is why I'm making this video, because I want to turn this project into an actual sort of like open source library that people can actually use in their projects in a modern C++ way. Okay, so just as a recap as well, I've got a little diagram here that essentially just explains the whole idea. So the library that we have is essentially going to be like a little shell, right? So you're going to be able to type a command, so add 1 and 5, and then that will return you like 6, for example. And if you do echo hello world, that will just say hello world, right? And this whole thing is essentially what we're sort of modifying right now, and it does work currently. I will show you the program that I've done in a little second, but the main idea is the following. So whenever you use this library, there will be a big command map, okay? And the command map is gonna, the keys are gonna be something like the actual command name. So in that example I just showed you guys, add will be one of them, and the key, the value is going to be a function pointer, a lambda, or sort of like a functor in C++, where whenever that person calls add 1 and 5, that command is then going to be parsed. So it's going to be split into spaces. The arguments are going to be separated from the command name. And when the command name is add, we basically just call this function here with the parameters that the user called, right? And this is just a number here to represent a function pointer, but what I mean here is that this is essentially just going to be a lambda in C++. In fact, can I do a text just so you can, something like, this is what we're going to have essentially. This is what our map kind of stores for us right here. So each command is going to have a handler, right? In a way that whenever you call the command, it splits the arguments, and then the handler is called with the arguments. And this kind of already works. We already have that in the library. So if I just run the actual example for you guys, this is something I added today. If I just build what we currently have, you can see kind of how it does it. So I'm running the program now, just gonna zoom in a little bit. And if I go on the terminal, I can actually, you know, this is the program, this is the REPL program. I can do something like add 1 and 5, and it'll give me 6 back. I can also do echo hello world, and it'll show just hello world, right? And I also added an exit, I think it's called quit command to just quit the program. And this is essentially it. This is what we're gonna be using as a sort of a debug executable here. So this program is using the library that we created that contains all of the implementation for the specs of the challenge. And I'm not going to go into the specs too much again, because we've already done that in the last video, so you can watch the previous one if you're interested. But essentially, you know, we have functions to add a command here. Oh, let me actually go back to the main API. There you go. We've got this class called the command interpreter, which essentially just has functions to register a command. It has functions to queue a command. So this happens whenever a user inputs a command. You just put the whole string here, and it'll pass that string as a command. We can also set the callback to all the commands. Actually, it's just one callback at the moment, but that's something we're going to change. We're going to add a unique callback per command. Okay. And then poll, which is the function that actually executes whatever's on the queue currently. Okay. So yeah, I mean, what we did last video is I started to basically just refactor this class here and actually expose that to the users of the library. And by that I just mean like I essentially split out this interpreter class out of the previous sort of C style library that we had for the actual challenge, because that's what they asked for in the challenge, into a more modern C++ library here in CMake. So this is where we stopped actually. So I've basically separated the command interpreter stuff into its own target. So as you can see here, I've got the command interpreter impl, which is the class itself. I haven't really changed the file names so far, but that's something that we can definitely do. The command types helper, which is just helper functions for the library to work. And it's all like in the, I guess the public API, although it's not something that we're gonna, not all these functions, not all these files are gonna be exported in the end. That's what I'm trying to say. If I try and basically just get back to the branch where I was doing this refactor, right, which is a branch I created. You can see here source interpreter, and if I'm not mistaken, it's not actually building. So there will be some CMake work today, hopefully. Does it build? No, it doesn't build. There you go. So interpreter, command interpreter, fatal error, no such file or directory. So it's not finding this file here. And why is it not finding that file? Well, it's probably because of the CMake I've written. It's not quite right. So what we do here is that's zoomed in too much, I guess. I'm defining a library by the name of REPL interpreter, and that's the target name in CMake. I also have targets include directories, which basically says that the include directory, whatever's inside the include directory, is going to be publicly visible to all the dependencies or the dependees of the REPL interpreter target, which is fine. And then I'm just doing some stuff here to generate the export header. And I'm not going to go too much into detail about this one, but we did look at it in the last video. It's just a way to tell CMake to generate me an export header with all the macros for exporting classes and functions in C++. But yeah, I mean, everything inside include interpreter should really be found here, and it's not actually working because the name has changed, I think, right here, right? So if you look at the include directory, it's inside the interpreter. If we try and build it again, what's going to happen? Interpreter. There you go. Now it's in a different file, I guess. Yeah, so again, here is just a new interpreter. I think I'm spelled that. Interpreter target that I added. Interpreter. There you go. And I guess there will be some on these two. So the idea is to replace whatever the old API was being used in the old code with this new target here, okay? And we're going to rework some of the CMake today as well. Okay, that looks a little bit better. Interpreter. Yeah, so this one, we don't really have the... Yeah, so this one actually depends on the main API of my function, or the main API of my library. You don't like typing screw reports, but... Bobby. Hi Bobby, you don't like typing school reports, but you do like typing code. I guess so, yeah. I don't know how you know that, but I don't think anyone likes typing school reports, do they? But yeah, I mean, this dependency here is on the actual control header that I had for the public API of my my library itself. So what am I actually using from there? Let's see. So if I just remove this for now, is it going to compile? And again on this one, let's just remove that for now. I just want to see which functions have been used from that header. Interpreter lib export. Okay, so this is definitely not needed anymore. Yeah. This one should be something else. This one should be the new export header that we generated with CMake, which is called interpreter export. Just to make a search on the same directory first, we do this in C++. Let's rebuild it. Bobby again, why would someone choose C++? So many changes while still trying to be compatible with code from the 90s. Make it super difficult, as it has become an encyclopedia now, right? Yeah, so that's the good thing about it as well, I guess, Bobby. It's because a lot of software written back in the day that's obviously still being used, especially when it comes to sort of embedded systems or OS features and whatnot. Even in the sort of Windows environment, Microsoft is quite big on C++ still. Yeah, the big advantage of C++ is that it still works. So whatever software you're going to write now, or whatever software you wrote, 20, 30 years ago, it's guaranteed to still work even on modern compilers, just because of that sort of like very strict standard. So yeah, I mean, that's one of the advantages. And of course it can be a disadvantage as well, because it just means that, if you take a look at code written a long time ago, it looks nothing like modern C++. So yeah, thank you, Supersmart. Thank you, but yeah, I wish I was, but I'm hoping that you can become smart as well. Are you a student? What are you doing right now? Are you studying programming? Are you just doing it by yourself? What's your situation? Command function. Okay, so my control header is actually defining this. So I guess what we can do is I can just, for now, I can duplicate it and then just put it over here. There you go. And if I just I'm gonna rename this to public API. We don't need that anymore. But I am gonna replace this with the old export stuff that I had. I mean the new export stuff. Which was simply interpreter. And I've got interpreter command export then. And if I actually take a look at this, what am I looking at? I need to include this header somewhere so it kind of works. Finish my study, wish I programmed more back in the day. I want to become a better programmer, but I don't know what kind of projects I can work on to increase my skills. So many topics, memory, GPU. Yeah, it's, to be honest with you, Bobby, I still find it difficult, even for me, to find a project I really enjoy and work on my free time. You know, most of the programming I do is probably at work, obviously, where I spend 8 to 9 hours a day actually sort of doing code. But the most learning I do is outside work. So that is, you know, in many different projects on GitHub, or just watching people on YouTube. I learn quite a lot doing that as well. But yeah, I mean, when you can find those projects, you're gonna have a much better time. Just make sure you find something that you actually enjoy. You mentioned that memory, GPU. There's a lot of very famous, very popular sort of topics nowadays, especially with the rise of AI. If you're looking at GPU stuff, you're gonna have a fun time with AI, because there are many projects like the NVIDIA project and so on and so forth that actually uses a lot of GPU programming. But those tend to be quite long though. They tend to be very boring to do, in my opinion. So I see a lot of new people trying to get into those topics straight away after they finish their studies, but I don't realize that, you know, sometimes it's more enjoyable to work on something simpler, and something that you can actually start and finish. If it makes sense, you may feel more enjoyment in that. So yeah, right. Let me just compile this again, because I've lost what the issue was now. Okay, man. Thank you for tuning in on this past 5 minutes or so, and have a good evening. Hope you have a nice meal. Bye bye. Argument type has not been defined. And why is that? It's because I don't have the public API. There you go, guys. I need to put it to do here. I need to rename this header, because I don't have anything better to call it right now. Yeah, so we have actually got some issues on the header public API, and that is because the interpreter export header. There you go. This is what I want instead. Yeah, this is again just I guess a change in the naming for my export stuff. I copied one extra space there with Vim, unfortunately, so I need to remove it at the start. Any more? Okay, so this should hopefully compile now. We'll get further. There you go, we've got further this time. And that's just a mistake there by me. There you go. At least it compiled now, even though some of these functions are not defined, we're still not using them. But we're getting one step closer to actually turning this into a proper CMake target. And I'm going to change this public API. Right? What are we going to do here? We're actually going to write those functions that we spoke about in the last video. Right? So there will be a function to, if I'm not mistaken, to make one of my object types. And can I see that? There you go. So I've added them as comments here in the last video. The first big change that we're going to do is in the proper library, we're going to have a function called makeInterpreter instead of the initialize function, right? In that way, we could have multiple interpreters because of the, if you've not watched it, if you've not watched the first video, I spoke about how we could only really have one interpreter running at a time if you use this as a plugin to your program or as a simple static library, just because it's a singleton, and that's kind of what they asked for in the interview challenge specification. However, it's not what I want to do. If I wanted to make this into a useful library, I want to make sure that the user can sort of have their own pointer to the interpreter object, and it won't be sort of like managed globally in one object. Okay, so that's what we're gonna do. So if I go to public API, all I wanted to do is just basically replace this with this, right? And obviously I want to kind of export that. So, and I also want to include memory here. There you go. Now interpreter is not defined right here, and why is it not defined? And let's also move this function into kind of like right there, I guess, inside the namespace that it should be on. So make interpreter cannot overload functions distinguished by return type alone. And why is that? Why is it telling me that? I don't know what make interpreter is. It only appears here. Maybe this is a fluke. And yeah, this comment is obviously going to have to be redone as well. The documentation. Yeah, okay, so interpreter does exist now, as you can see. In fact, command interpreter impl, okay. Yeah, see here we have an issue where the public API is exporting a function called makeInterpreter that returns the interpreter class, right? But then the definition of the interpreter class is done in the command interpreter impl, well, a H, I guess. But that itself, okay, no, it doesn't. Yeah, it doesn't. I thought it would require the public API. That's fine. In fact, yeah, a much better place to put this would just be to leave it right here, I guess, right? There you go. With the class, just leave it there. So whoever includes this class is going to have access to this function as well. Okay, good. So what would this look like? Firstly, I've got memory there. Let's actually kind of define this function. So it's just going to create an instance of this class here and return that to the user. That's all it's going to do. Nothing else needed. So okay, so I'm going to put in the command interpreter impl .cpp file. Okay, so here we have std unique pointer of interpreter or cmd int interpreter class. Is that what it was called? Oh no, it's called REPL. REPL interpreter? No. REPL interpreter register command. Yeah, it should be that. Interpreter. And then we've got REPL make interpreter. Is that what it was called? I do not remember. But we're gonna go with this anyway. Why is unique pointer not here? STD has. Oh, okay, yes, because I made a typo. That's why it's not there. I forgot what the shortcut is to go back and forth between header and source file in C++. And that kind of bothers me a bit. Let's not save that. So it's the C++, and we have this here. Make interpreter cannot overload the functions. But where has this been used? I'm still complaining about that. Ah, okay, I didn't remove it from my public API, I guess. There you go, now it doesn't complain anymore. Okay, so now we just gotta kind of implement that function and include the right headers. Okay. That is it, I guess, right? There's nothing else. What's it complaining about? Make interpreter. Make interpreter. What is the issue here? Namespace REPL. No idea why it's not kind of letting me do this. But what happens if we just compile this? Should have been declared inside REPL. Which is what we did, isn't it? REPL make interpreter. Rest the unique pointer should have been declared inside REPL. Is this not inside REPL? This is namespace REPL here, right? Or am I doing it wrong? I don't see what the error is here. So that's one of the things with C++ as well, compared to other languages. The errors are absolutely shit. Really, really bad. It's saying that this function should have been declared inside the REPL namespace, but we do have that inside the REPL namespace. Unless I'm not including the header file itself, but it's here. Look, it's just there. Ah, that's why. There you go. I think that will probably work a little bit better now. Command interpreter impl. Interpreter. and I probably don't have it in the CMake file as well, so that's why. So interpreter CMake lists. Oh, that is definitely here. That is definitely here. Interpreter command interpreter import.h. Interpreter import.h. Yeah. Why is this include not working? Interpreter. Wait a second. I've got this file here and this file here. Huh? I'm so confused. What is this one? Ah, this is the old one. Okay, this is the old one, yeah. That's why. Yeah, that is why. So I shouldn't be modifying the old one. It's because I changed things without removing the old file. So this file here should disappear. We can delete that permanently for now. And the changes should have gone in here now. And now if I build it, it should somewhat work, I guess. If I've got the right interpreter, the right header files. No rule for targeter, command interpreter import needed by. Yeah, I mean this is just a CMake. We don't really care about the CMake anymore, so the original one. Let's actually do a little bit of refactoring in CMake now. So we do care about this code. Just checks that the root project is, it has a project name, I guess. So it's the root project for building purposes. It sets up the project metadata here. Language C++. We want the standard settings here as well. We don't care about this. We want to compile for whatever kind of architectures you've got, really. We want to remove the add library shared here. We don't really care about the target anymore. We don't want this here anymore. Let's remove it, because now what we have is, can I just do this for now? Comment, how do I comment? Control Shift comment? Nope. I guess I'll comment line by line. We don't care about the test for now because we're just refactoring everything. The if win32 stuff, I would probably leave this here. I do explain why it's needed here. And yeah, here we go. So the install stuff, we don't need it for now. We're gonna install the CMake stuff later, right? Let's try and build it and see how it goes. There you go. Now it's fine. So what did that do? Well, basically we just want to remove everything that's not inside this interpreter. So command examples, I guess we can delete it as well. Or should I leave it here for now, because it does actually have the handlers that I created previously for functions like add and echo, so we'll leave that there. Control, we don't need it anymore because I moved that over to the proper interpreter target. And sanity tests, I'll leave untouched. But yeah, let's now actually go back and see. Okay, yeah, cool. What is the issue here though? Okay, no, this is not going to be compiled anyway, so. Cool. And just as a quick sort of note-taking thing here, all that I've done is like I've moved all of the sort of like the CPP. So the project has the following. So we've got the interpreter, right? Interpreter. And I apologize, my handwriting is terrible. So this is a library, right? And that itself will contain the source file, right? The source code will contain the includes. I can't spell it. And the actual CMake, right? Some CMake code for the target. So the target here is basically just, you know, it's called, I think it's called REPL underscore interpreter or something. All the include files are inside interpreter. And we've got / includes / interpreter as well. And then the source file is all inside the interpreter directory. So this is how the CMake project kind of looks at the moment. This is it. This is all we've done so far. So we just wanted to kind of like properly lay this out for the CMake build, right? That's it. So we've got kind of like, if I can interpreter, I'm going to improve this a little bit. We've got includes interpreter, SOC, sorry, SOC interpreter, include interpreter. And we've got the source files, those are the CPP files, I guess, with the actual definitions of our functions and so on and so forth. That's inside interpreter. And then the CMake for it, so the target CMake is inside SOC interpreter. This is it. And this is sort of like the project structure so far for our project, right? There you go. So with that out of the way, we're starting to add new functionality to the stuff now. So basically refactor the functionality that we had previously. So the first thing we did is we had that little class of ours, which was called the interpreter class, right? Here, and this is what we want to export to the user. So whenever you want a new interpreter, that will take control of that command map. We need to have it to have an instance to this class here, and that's basically what the make interpreter function does. It's not that difficult. Now we don't, because it's a unique pointer, we don't really need to do anything else here, because it will be destroyed automatically when that pointer goes out of scope, and because we don't really have anything fancy going on here in the lifetime of our class, this is pretty much it, right? So let's merge it in. So far, you know, this is fine. Let's, I guess, add all of this to GitHub. Opa. I don't think there's anything I needed to add. Oh yeah, of course. I didn't actually add the code that we've created, I guess. So I'm gonna have to fix up here to add that in the previous commit. So they should have been part of the previous commit, so obviously I'm gonna have to rebase interactive here and just do a fix up. A fix up in Git, if you don't know, is just a way of like you create a new commit and then edit the previous commit so that the current commit that you've made basically just merges in as part of the previous commit. So this commit here is all the changes inside this commit are going to go inside this commit. That's all it means. And of course, because I've changed the history, I have to force push it. And that is it. Okay. Now, a cool thing to do would be to, I guess, merge this into a main, right? So we can, I guess, if we're doing this properly, we can create a proper pull request here, but you know, there's no need in this case. I can just merge into main straight away. So what did we do here in this work? I just created, you know, I refactored the CMake project. Or I just created the interpreter. Target and CMake. Plus CMake improvements, right? This is Studio Ghibli, kind of like this. Okay, so now if I go into my main directory and then main branch and pull, I should have those changes. Cool. And what I'm going to do now is actually get that program that we've created that actually does the polling for the user commands, I guess. And we're going to put these changes into that branch so we can then push it into the main repository here, right? So let's do that. Let's do exactly that. So REPL executable, and we are there now. So we're gonna just, I guess, fetch origin main, and then we're gonna rebase this. So all the changes are included, or will be included here. There you go. There will be conflicts. Obviously, there will be conflicts. So if we look at the REPL CMake file here, let's see what the conflicts are. So none in this file. So what do we want? We definitely want to have the, we want both changes, really. We definitely want both changes. We want to remove that one there. Okay. Because we wanted to comment the previous sanity tests, stuff that we commented out. And we also wanted to add the new REPL executable here. So let's add this one. And then we also have the interpreter, command interpreter impl, right? Interpreter, command interpreter impl. And what is the conflict that we've got here? Yeah, so I needed that. There is just a bug fix from this branch. Let's do that. So I definitely want that as well. And yeah. There you go. So now I can do it, rebase, continue, and hopefully it will have done everything. I have to push force release because we did change the history. When we rebase, we pull the changes from main into your current branch, but those changes will be changing the SHA commits of your branch as well. So hence why the force push. And if we build this, does it still build? No, it doesn't. Of course it doesn't. Because this still has the old, I guess, the old includes, right? Which we don't want anymore. What we want to do is essentially to remove this the old dependency on the old version of the API that we changed and call a new one, right? So I think that was called REPL interpreter or something. Yeah. Okay, and in here, let's just change those includes over. Include interpreter should come up now. Yeah, the language server has crashed, unfortunately, so we have to wait a little bit. I'm going to take this time to drink some water, stay hydrated. Okay, maybe, just maybe, we will have to just close Visual Studio Code and open it again. Okay. There you go, now it's fine here. And the one is the actual impl here. Does this call the public API? I have no idea what this is finding there. We've got two exports, one should go, really. Ah, okay, it's coming from public API. So obviously we don't want these anymore. In fact, if I look at all these functions here, we should remove all of them. All of them just need to go. This is the old API, we don't really care about it anymore, so I've removed one too many and ifs there, so I'm going to do it again. There you go. I don't even know what this public API does, it just defines some handlers and arguments. This should be called, I guess, interpreter types, right? That's something we can rename this to. If we look at REPL now, there you go. Good, none of these functions are available anymore, which is fine. I mean, what we want to do is to have, or be calling the functions that we've defined here, essentially, right? So first of all, we want to call REPL.make interpreter. So we can actually use that interpreter on this executable. And I've just realized that I didn't actually explain what this executable does. So this is the REPL executable that I showed you guys before. So if we just take a look at the build directory here, you see kind of what it does. Or maybe not. It just basically it's just a program that takes user input, and then on that user input is going to assume that that's a command and then send that to the interpreter and then execute it, show the results, and then you'll continue to do the same thing over and over again. Kind of like Bash, just on the screen here. So I'm just going to refactor that program again. It's not anything too difficult to understand. As you can see, it's just like 40 lines of code. So what it was doing before is it was initializing the library itself, and then it was registering some commands. So echo, add, and quit, which are all the functions that I defined here, the handlers that I've defined. And then it was just a forever while loop until the user requests to quit the program. And quitting is basically just at the moment, it's just a global variable up here, a static Boolean, which is false at the start of the program. But then whenever a user types quit, that quit variable, that handle is gonna set that variable to true. And hence why the while loop can then kind of exit, right? So that's what we're gonna do. So let's call make interpreter here. So we've got the interpreter, and with the interpreter we can call the register functions. There you go, register command. And what do we have here? We've got the command name. It will basically be the same as what we have down there though. Right, so basically a smart way of doing this would just be to replace all of this, I guess. register command. I've got interpreter. Is it called register command? Or am I tripping? Yeah, it's called register command. Yeah. Okay, so this is what it's going to do. I'm just going to make sure the function is the same as it was before, which it is. Obviously, we changed the name of the namespace for the example commands. Right? Maybe not. Yeah, I mean, previously those example commands were all here. Right? So let's just get the ones that we actually care about, I guess. So which is the add one, right? Yeah, and then echo. This is all code that I've written beforehand. They're just functions to handle the add command and the echo command, which essentially they both take strings and then convert to the type that they need. So for example, add is obviously going to convert all the arguments into integers and then sum all of them up. Whereas in echo, we just display those out to the cout, basically. So let's just add whatever we had here in the REPL. Here, so right here. We see that there is an issue. So all these CMD ints were changed to REPL, right? I will explain some of the more complicated stuff on a different stream probably. So there's a lot of functions that are converting between variants to the actual types that we need. And these are sort of like really useful templates that I've got online, essentially. So if you look at convert argument, for example, it's a visitor sort of pattern implementation for C++ arguments, so the std arguments. And it was very useful from this website here that I got, and I wouldn't try to explain it to you now because even I found it very difficult to understand the logic behind it, but it does, you know, it does work perfectly, essentially. Commands type helper, which is an interpreter. Okay. I really do hope that my my keyboard has a really nice sound for the people who enjoy really good mechanical keyboards. Kind of like ASMR, really. But okay, so we don't need this. We need this to be interpreter, query command, or Q command, and then interpreter. Home. Okay. I wasn't expecting this to compile. Obviously there were going to be errors. So let's see what. Declaration of REPL command argument. Not a namespace surrounding REPL. Yeah. That's because it's not. It should be an anonymous namespace function. And same with echo again. Okay, better. Argument type was not declared in the scope. Which one is it? Argument. So this is in the public API. Confused. Very confused. Okay, no, this should definitely be there. So public API. Let's see if that improves things. I don't think it will. I think it'll still throw me that error. Oh yeah, it's because I'm in the anonymous namespace now, and we obviously need REPL. Yeah. Where was the second one? REPL. Okay. Aggregates O string has incomplete type. Yeah, that's because I don't have S string here. So I'm using the string output string stream, but I forgot to actually put the proper include. Echo handler is not a member of REPL. Again, this shouldn't really be. Is it? Ah, yes. It's because of this. Print callback is defined but unused. Okay, where is it? Ah, yes. This is the callback, so it should have been interpreter register callback or set callback. There you go. Yeah, as I said, at the moment we're still working with one single callback, so the same callback for every command that runs essentially. And the callback that we have for this particular program here, it just prints out the result, right? So whatever command you execute, that command handler is going to return some results. I think it's called command argument, this one here. And that command argument is then passed on to the callback. And I will explain a little bit more about this when, in the next video when we've got things a little bit cleaner, I guess. Okay, so let's clean rebuild this. And then we're fine now. So if I actually run the REPL program, things should still run. Oh, what is going on here? Working directory. What is going on? Build Unix debug, which should exist. Build Unix debug, source, REPL. REPL is here. File dir name. Ah, working directory should not be set. Maybe that's why. What is going on? Let's just copy this and put it here. Current working directory. Okay, let's try that. Okay, so we're setting the working directory for the debug to be the same as the executable. So hello world, it still works. Add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 55 as expected. And then can we still quit? Exit? Oh no, sorry, it's quit, isn't it? There you go. So our program still works, which is good. Good things to do. So now let's add this little program as a test to our GitHub, right? If you're wondering how I'm running all of this interactively here, it's kind of like an interactive sort of terminal Git status kind of thing here, where you can add your changes. It's just git add -i, and they will give you these options here. And then you type in the number on the option you want, and you take it to the menu that you've selected. So it's just something that it helps you work really quickly with Git, and you don't need a GUI to do all of this. Don't want that one. I want to update 1 to 4 here, and I can do things like adding files 1 to 4 by number, and then it will add you all the changes from like change number 1 to change number 4 here. In my case, it's fine because I know that all the changes here are what I wanted, but obviously you'd have to take a look at each individual change and see if you actually want to add it to your commit. That's it really. I don't need to force push this. Okay, so that looks better. So what do we have in the repository now? Let's just REPL executable. Create a pull request. Oh, I think one of the changes here is still under my work account. Oof. Yeah, no, this needs to be redone. So let's change that. I've committed it with a different account before, which was not correct. So yeah. So what can I do? Oh, I can't remember what the command is now. This is not the right one. Yeah, there you go. Okay, cool. So what I'm going to do is I'm going to rebase this so they are both the same commit. Oh no, don't want to do this. What I want to do is this though. I'm just going to amend the commit. To be my actual email and my name here. And now my work account should have disappeared. Hopefully, there you go. Great. Yeah, let's merge this in. I just wanted this to be a very quick one, just to finalize the CMake stuff. So far, the whole project would have taken at least 2 to 3 hours. This is well within the allowed time for this challenge. I think the time scale I was given for this particular challenge on the interview was at the time a week, so you have a week to do this whole thing. But it's something that you can do, if you focus on it like in 2 or 3 days max. If you spend like a couple of hours every day. So in the next video, I'm actually going to to once again explain the whole architecture and dive deep into some of the functions that I've written. So for example, the function that registers the commands and the function that sort of like queues the command into a queue for later execution and so on and so forth. Just so you guys can have a very good sort of like idea of how you should approach this and which bits you should essentially write first and start tackling, and how you'd normally test this kind of thing. So in fact, you probably start the whole work by writing some like pseudo tests in a notepad or something, how to use the library, and then you say if I type in this command, I expect to output this command here. Also, I can register commands and so on and so forth. So all those tests are something that you'd have to do beforehand before you actually implement, just because you want to have an idea of what you're trying to achieve. So that's pretty much it. But yeah, I mean, looking back at here, what do we do today? We have created essentially an interpreter library in CMake that has all the public includes right here in this directory. I'm not claiming them to be the perfect headers ever. In fact, I would probably change some of the names, and I'll probably delete 1 or 2 of the includes, the ones that aren't needed. But at least they're all sort of like secluded and isolated in an own like sort of directory in CMake, and their own target called interpreter. All the implementation of my header files and my functions defined in the header files are in the source interpreter, and of course the CMake target itself, or the CMake related stuff, is in my CMake lists inside the source interpreter CMake. So this is probably one of the first things that you'd kind of do when you're trying to create or write a challenge that includes some CMake. You just want to create your executables, your libraries into a target straight away, just so you can start coding, debugging, and so on and so forth. On the side, we also spoke a little bit about the idea of the whole project, which is basically just to have a map that maps, you know, the command name to a function that handles the arguments for that function. So whenever the user types, you know, add 1 and 2, it will split the this into a command. Actually, forgot a name there. The command, and then the args here, you know, into a list of args or something like that. And then this would obviously queue up that command that the user asks for, and then later execute it with a function called poll or something similar to that. But yeah, I mean, this is essentially what we've got here so far in this target interpreter. And in the upcoming streams, I plan to do maybe 2 more streams on this because in the end, this should take overall like 5 to 6 hours to complete if you sit down and then just do it and don't do anything else. 5 to 6 hours is I guess a suitable sort of time frame to complete this kind of challenge. Over days, this will be, you know, 5 or 6 days if you're working, or if you're just doing it full time, 2 days you should be able to finish this quite easily. But that's the idea, just take you guys through my thought process. So in the next stream, yeah, we'll take a look at the actual implementation of this whole this whole command mapping thing. And yeah, thank you guys for watching. I'm not sure if there have been quite a few viewers today, but if you're watching this in the future, feel free to post a comment. Let me know what the quality of the audio was like. I do appreciate when people ask me to improve certain things that I haven't noticed myself. And that's it. Bye bye, guys.